sine and cosine. If you look at your unit circle, we only have sine and cosine values. I'm going to tell you right now, if you know how to read those, this next section is pretty easy. It's just reading them and doing something to it. Read, I'm sure you're checking on the unit circle values real quick, but let's put our phone away. Okay, so today we're going to bring in the other trig functions. That is cosecant, secant, but more importantly, tangent and cotangent. Tangent is going to be kind of brand new. We can figure it out, but it's going to be something we want to have memorized and put on our unit circle, which we'll talk about in a second. So when we're looking at our unit circle, we talked about I think one of our first days of class, we talked about where sine and cosine came from, where we came up with sine equaled y and cosine equaled x. We drew a triangle to a point that was on our unit circle. So this is, basically, if this was our unit circle, all the triangles would have a hypotenuse of 1, and you'd also have an x and y to get there. So we said if I found the sine of theta, that angle, sine was opposite over hypotenuse, we said that would be y over 1, which just equals y. We did the same thing for cosine, where cosine would equal x over 1, which would just equal x. Now, tangent's going to be a different beast, though, because tangent is honestly going to be TOA. So we have TOA. Tangent was opposite over adjacent, TOA. Well, in this case, opposite would be y over x, which is really just your sine value over your cosine value. So it is find outable. It's probably going to be easier if we just memorize it, and we'll get to that in a second. Well, the big thing we have to keep track of, and the hardest thing to keep track of, is cosecant, secant, and cotangent are just reciprocals of our core 3. So it's just 1 over, which is easier to write as you just flip the fractions. It's flip the fractions, or you can put 1 over. The hardest thing people keep track of is cosecant goes with sine. Secant goes with cosine. It makes sense if cosecant went with cosine. Unfortunately, it doesn't. And I don't know if this helps anyone. This is how I remember it. It's not the right direction. It's kind of like how inside goes the opposite direction. Cosecant goes to the wrong thing. Cosecant goes to sine. Secant goes to cosine. It's the easiest thing to make mistakes on. But once you get track of those, it becomes really easy. Since cosecant is just 1 over sine, we could say it's 1 over y. So that's just 1 over y. It's going to be more simply, we just flip the fractions. So let's say sine turns out to be 1/2. We find the sine of 30 degrees, it's 1/2. Cosecant is you just flip it, it's just 2 over 1 or just 2. So cosecant is find all of your sine values and flip them. And you now have cosecant values. For cosine, it's the same thing to secant. Find your cosine value and then flip it, and you have your secant value, so that's 1 over x. But once again, since all these values, if you look at your unit circle, except for 1s and 0s, they're all fractions. Fractions that can just be flipped. So if I ask for the secant of 30 degrees, you first find the cosine, and then you flip it. So if you look at your unit circle, although it's cosine and sine, if you flip both of them, they become secant and cosecant. Then if you know the tangent value, you could just flip it, and it becomes our cotangent value, which would be our x over y. But once again, I want us to keep in mind, don't worry too much about this stuff. Think about, what do I do with the fractions? How do I use this on the unit circle? And on the unit circle, it's really just flip your fractions. That's all I'm asking you to do is flip your fractions. Okay, we have a little blank here for a couple things. First of all students take calculus. Now we have to make sure our computer's away, please. Thank you. We're going to use all students take calculus, but we're going to expand it a bit. So we have all students take calculus. All is easy. Everything is positive. Everything is positive. Students, we said sine is positive, right? And then unfortunately, we were at the stage where we could say everything else is negative because we only had cosine. But not everything is negative. Since sine, the only difference between sine and cosecant is they're flipped, the sign will stay the same. So if sine is positive, so is cosecant. So if I know sine is positive, cosecant will also be positive. So in quadrant 2, cosecant is now also positive. Take, we said tangent was positive. We didn't really think about it at the time because we didn't really know tangent. So now we can actually put, if I get a tangent value in the third quadrant, it's positive. But that means cotangent is also positive. And in quadrant 4, that's all students take calculus. Our cosine is positive. Now before we said everything else is negative, but not everything is negative. Secant will be positive in this quadrant as well. All right, then I took something out of this box, but it's not important. That's why I got rid of it. But I did want to point something out. I wanted to note something. I'm going to put a big old note right here for future things in the box. Note. We're flipping fractions. Fractions are going to have, also we're going to put square roots in the denominator. So let's say I also come up with 2 over square root of 2. We can't have a square root in the denominator. How do I clear out a square root that's in the denominator? A dead read is there, yes. Yep. We multiply the denominator and the numerator by square root of 2. Now, square root of 2 times square root of 2 is the same thing as square root of 2 squared, which cancel out the square and square roots. Square root of 2, it just, not 1, but it turns into 2. It basically, the square roots cancel out.
Oh, just whatever's in the thing?
Whatever's in the thing is what it is. So I've had square root of 4 times square root of 4, it turns into 4. As long as they're the same. Square root of 4 times square root of 3 doesn't work that way. It'd actually be the square root of 12. One way you could look at this too is square root of 2 times square root of 2 is actually the square root of 4. Because you multiply what's underneath it, which is 2. Well, this cancels out, and we'd have square root of 2. I'm going to do that with one more key thing. We're also going to see something that's 1 over square root of 3. Follow that same process, multiply the bottom and top by square root of 3. Square root of 3 times 1 is square root of 3, and square root of 3 times square root of 3 is 3. Thank you. Boom. We need to know those conversions because we don't have a ton of room in those boxes, so we did it up there to make our life a little easier. Okay, let's go ahead and get started, and we're going to label all of these based upon the fact that we should know sine and cosine right now. We just took a test on this. We should know these values. What is the sine of pi over 6? That's our key. What's the sine of pi over 6? It's our first mark. What is the sine of pi over 6? It is 1/2. It is 1/2 because sine goes 0, 1, 2, 3. So at pi over 6, sine equals 1/2. What's sine of pi over 4 then? Bless you. It's square root of 2 over 2. What's the sine of pi over 3 then? Square root of 3 over 2. These are things we should actually start knowing without having to look at our unit circle. All right, if I know sine is 1/2, what does that make cosine automatically? Square root of 3 over 2. If sine is square root of 2 over 2, that means cosine is going to be square root of 2 over 2. That should be the easy one. Anytime it's over 4, it's square root of 2 over 2. And then finally, cosine of 1/3 should be 1. I'm sorry, cosine of pi over 3 should not be 1/3. It should be 1/2.
When you said pi over 4 is square root of 2 over 2?
Yeah.
So
It could be positive or negative. No, I'm talking about sine and cosine.
Oh.
So if I gave you 6 million pi over 4, you go, okay, I know it's square root of 2 over 2. I just don't know if it's positive or negative because I don't know what quadrant it's in. Because that reference angle will always bring it back. Yeah, square root of 2 over 2 should be the easy one. If it's over 4, it's square root of 2 over 2. It's just, is it positive or negative? We know we're in quadrant 1, so it's all positive. Now, the very first thing is we're going to do tangent. Tangent is going to be sine over cosine. Sine over cosine is going to look like this. And in fact, I'm going to come up here, and I'm going to put a little arrow right here, that this is sine over cosine. And it'll be sine of pi over 6 over the cosine of pi over 6. Well, sine of pi over 6, we said, was 1/2. The cosine was square root of 3 over 2. What do I do if I have a fraction over a fraction?
You multiply it and then you flip it.
Yeah, we could do keep change. There's 2 ways we can do this. First way is keep change flip. That's what I kind of heard. So we turn this into 1/2 times 2 over square root of 3. Or you can just multiply the top and bottom by 2. 2 over 2 will also clear those. All right.
So then it's just 1 over 3.
Yep. So we're going to have 1 over square root of 3, which I'm going to write right here. But we can't have a square root of 3 in the denominator. We just simplified that. Yeah.
Why are we finding, dividing? Is that find cosecant?
I'm not finding cosecant. I'm finding tangent first.
Okay.
Yep. That's why I had that arrow pointing to the tangent. That's the one we're doing first. I'm going to find our 3 big ones. Sine, cosine, and tangent. Tangent is sine over cosine, which our sine value is 1/2. Our cosine value is square root of 3 over 2 in this row. So that equals 1/2 times 2 over square root of 3, which we said equals 1 over square root of 3, but we simplified that up above.
So it's square root of 3 over 3?
It should be square root of 3 over 3. Let's do our tangent all the way down first. Because once we have tangent, everything else is just flipping it. So our next one is sine over cosine, which is square root of 2 over square root of 2, all over square root of 2 over square root of, or over 2. You could do keep change flip.
You just take out the 2's.
You could take out the 2's. How about something easier? Is it the same in the numerator as the denominator? So it equals 1. No matter how fancy it looks, it just equals 1. You'll come up with the same. I've seen plenty of tests and stuff where people do the whole thing and it comes out to 1. It's fine. There's no points taken off because you did extra work, but you should start realizing if it's the same thing on top and bottom, it just equals 1. Okay, our last one is tangent of pi over 3 equals. Now, this is sine over cosine, but it's going to be a little different. We should be able to fit this in the boxes as long as you write it in small, like I am. Square root of 3 over 2, 1/2. We can multiply the top and bottom by 2, which makes it easy. It's just square root of 3, right? If you multiply the top and bottom by 2, it's really easy to see that square root of 3 over 1. But if you don't do it that way, it's fine going the other way. That's square root of 3 over 2 times 2 over 1. The 2's cancel out, and you're just left with square root of 3. So tangent has 3 big values, and that's square root of 3 over 3 and square root of 3. And there's a 1 in the middle. It would behoove you to memorize these, and we'll add them to our unit circles, the ones that you have, those yellow ones. We'll add the tangent values to it to make your life easier. We should start working on memorizing those because you can divide sine by cosine, but it takes so long on a test that you probably want to have them memorized.
So these numbers, right, like all of these.
I'll bring one up that has all the tangent values on it so you can just copy it onto yours. Okay, don't worry about copying it now. I'll pull up a sheet and you're going to see it. All right, that's the hard thing is tangent. The easy thing is the rest of these. Notice I have bolded sine and cosecant. Sine and cosecant are linked together. They're just reciprocals of each other. You just need to flip the fraction. So some people will write this as 1 over 1/2. So I took the sine value and I don't. I just flipped the fraction to make it 2 over 1, which equals 2. Just flip the fraction. Don't make your life any harder than you. Don't do the ones over. Just flip that fraction and you have your value. So secant. Secant goes with cosine. You just need to flip the fraction. Unfortunately, we run into that little bit of wall, so maybe put arrows if you're not. So I'd put an arrow going here that this just flipped that fraction. It turns into 2 over square root of 3. That means I need to multiply the top and bottom by square root of 3. which equals 2 square root of 3 over 3. Yeah.
Wait, isn't it? Oh, yeah.
I guess I'm like still confused on how I got pi 3 from 2 over 1. Oh, the multiple. I didn't see that. Never mind. Okay.
Are you sure?
Yeah, I got it.
Okay. All right. I don't want to lose anyone behind. It is.
I didn't see that you multiplied it.
Oh, gotcha.
That's my bad, yeah.
Okay, no, you're good. I just want to make sure we're up to on
Yeah,
the
we're good.
cosecant and secant. Make sure we're on the same page. I don't want us to overthink cosecant and secant. They just flip this. Like, if you know how to find the sine of pi over 6, you should be able to find the cosecant of pi over. It's just flip that fraction. And maybe you have to simplify it. I would highly suggest you do not write these on your unit circle because it is just flipping them. It'll take too long to do a unit circle if you're putting all 6 of these on there. But you should have time to put sine, cosine. Yeah, cotangent. Just flip this fraction. It will become 3 over square root of 3. Multiply the top and bottom by square root of 3. We would have 3 square root of 3 over 3, which just equals square root of 3. There's a shortcut for this. If you would have taken the reciprocal of this one, you just would have had square root of 3 over 1 and you'd be done. I just don't like doing that because people in your notes get confused when you see that. That's it. You do that one and you know the rest of them. Now, if my sine of pi over 4 is square root of 2 over 2, don't simplify it, but what would my cosecant of pi over 4 be? Not simplified. It would flip it. So it'd be 2 over square root of 3. Not simplified, it'd be 2 square root of 3. Or, sorry, 2 square root of 2. Multiply the top and bottom by square root of 2. We'll have 2 square root of 2 over 2, which just equals square root of 2. But we did that above there. What would secant of pi over 4 be then? 2 over root 2 as well. Which you do some math yoga on that, and you should come up with square root of 2 because we just did all of that work. Cotangent of pi over 4. We look at tangent. Tangent's 1. What happens when you do the reciprocal of 1? You get 1 out. You do. So that's just going to equal 1. I mean, it's basically 1 over 1 and you flip the fraction, but I don't know how to show that you're going to put in your notes, but it is just the reciprocal of 1 is 1. Cosecant pi over 3. What would the cosecant of pi over 3 be? Don't have to simplify it, I just need to know. 2 over root 3. Root 3 this time. Because we got that root 3 here. So 2 over root 3 or 2 over square root of 3. Multiply the top and bottom by square root of 3. Which is going to equal 2 square root of 3 over 3. And that's as simplified as we can get it. What's the secant of pi over 3? 2. 2 over 1. You could put 2 over 1 if it helps you, but I'm just going to put 2. And then the cotangent of pi over 3 is square root of 3 reciprocal.
So 1 over square root.
It has to be 1 over square root of 3. Which will turn into the square root of 3 over 3 is correct when you multiply the top and bottom by square root of 3. Wow. So we didn't add a ton. Can we not write so much on these? Thank you. It's basically just reciprocals. We added tangent, but everything else is reciprocals. And the big thing is cosecant goes with sine.
So as long as I know these 6, the first 6.
You know all of them. Yep. So we're just going to add tangent to our unit circle. That's all we're going to add memorize-wise. And the reason why I say it's not too bad to memorize it, because it is just square root of 3 over 3, a 1, and a square root of 3. It gets a little bit dicey on the up, down, left, right, but we'll talk about that in a second. All right. That's our big thing in our lesson. The second thing I want to talk about is how to use your calculator to approximate values. So if we could go ahead and take out our calculators.
Wait, can't your calculator do this?
It can't.
It can't?
It can't give you square root of 2 over 2. It'll give you a decimal approximation.
But can't you do in the decimal into our mode for that?
Nope.
There's
A
not.
fraction you can, not into a square root.
Not the decimal into the.
Not into a square root. You can turn it into a fraction. So if it's as long as it's like 2 over 3, as long as it's a rational expression, it won't do irrational. So it won't have like square root of 2. Because your calculator is going to round it eventually, and it's not going to know that square root of 2. That's why we let you use your calculator, because if it did that, we wouldn't let you use your calculator on the test. Okay, so use your calculator to approximate the values rounded to the 4 decimal places. We need to know 2 rules with your calculator right now. First rule, you have to have it in the right mode. This will be on the test, so probably a good idea that you actually have a graphing calculator so you can follow along with me. Your mode has to be correct. Notice how this one has pi in it and this one has degree. So when we're doing this one, and I'll bring out my calculator in a second, but we need to be in radian mode. And if you hit your mode button, it's kind of near your top left. You're going to find a place, and I'll bring up my online one in a second. I'm just pointing out some key things that this needs to be in degree. So your calculator needs to be in the right mode to plug in your values. The second thing we need to know is, where are these buttons? So what we're going to do is we're going to look at our calculator and we're going to find our secant button. Did anyone find the button that says SEC?
SEC.
Yeah, secant. SEC. Did we find like a sine, cosine, and tangent button?
Yeah.
There is no secant. There is no cosecant. There is no cotangent button. To use your calculator on this test, in the part that says approximate, you have to make sure you can put your calculator in radian mode, which we'll go through in a second. And you also have to know that there's no such thing as a secant button on your calculator. There are some buried in there, because what they figure out is mathematicians are smart enough to know that the secant is actually 1 over cosine of pi over 12. So to plug this into a calculator, you need to know it's 1 over cosine of pi over 12. You need to know that. So even though I let you use your calculator in this section, it's not easy because you have to understand how to plug in your calculator. All right, I'm going to go ahead and I'm back out of here. Possibly. Okay, cool. I'm going to bring up my calculator. If my mouse, I need to get a mouse pad in here. This mouse is janky. Where are you? There it is. Wait for it to load. No, I hate helping. Okay. Okay, we're good. Okay, so the first place we're going to go is that mode. Do we find that mode? Okay. Make sure it says radian. It's bolded in. If it's not bolded in, you're just going to scroll down.
Oh, mine's in degree.
Yep. So make sure you scroll down so it's flashing on radian, and then hit the enter button.
Where's the enter button?
It's bottom right. Then you can either hit second quit, or you can hit clear. Most of ours will back out if I hit clear. Clear does not work all the time. So know where second quit is, because sometimes it just, I get in the habit of second quit, but on here I just want one button. Okay, now we know that we cannot plug in the secant. So what we're going to do is we're going to type in 1 over, so 1 divided by, and we're going to type in cosine. It's going to open a parenthesis. We're going to hit our pi button. Your pi button is right above your caret button, but it's in blue, so we have to hit second. How do I get out of that? So I'm going to hit second. I'm going to hit the blue thing. I have pi. I'm going to hit divided by, what is it? Is it 12?
Oh,
12. So I'll type in 12. I'm going to close the parenthesis, and I'm going to hit equals. Now on the test, if you typed in 1, or you wrote 1, it'd be incorrect, because the directions do not say just put 1.
I did like a fraction. So is that fine?
Ew.
Oh, I have the same thing.
Okay.
Yeah, some of those will show it as a fraction, mine doesn't.
Okay.
Yeah. Because it says that we're supposed to round it to 4 decimal places. So 4 decimal places is going to give me, I lost it, but I think it should be about 1.0353 would be correct. Now the next one we have to know 2 rules. Our calculator must be in degree mode, and cosecant's not one of our buttons, so we need to turn this into 1 over sine of 123. So now we go back to our calculator and put it into degree mode. We just took it out of radian. It's okay. I'll take a second.
Oh, so now you put it in degree.
Now we're going to put it in degree mode. So I'm going to go back to my calculator and go, oh, they gave me degrees, so I'm going to go to my mode, which is that top left next to the second button. I'm going to see that radian is bolded, so I'm going to scroll down to radian, and I'm going to hit right so that degree is flashing. Then I'll hit enter, and you'll see it shifted over to degree. Now you're in degree. Now I'm going to hit second quit or clear, and now I'm going to do 1 over, and this time it's sine, and we're doing sine of 123. 123 degrees. Hit enter, and now we have 1.192. Is it 4 decimal places?
Yes.
So 4. So go back up here, and we're going to have is about 1.1924. So most people that get this wrong on the test are really just people that either don't practice on their calculator or don't realize that this button doesn't exist. The secant button, because it doesn't exist. So you have to put it as 1 over. So the whole trick of this is knowing that you have to put it 1 over. The other one that trips up people is this one. Because I'm plugging the calculator, I have to tell it whether it wants radians or degrees. So I have to know if it's radians or degrees.
That's radians.
This is radians because there is no degree symbol.
So you have to change it back to radians?
So we'd have to change it back to radians. Yep. And we should also make sure we use 1 over tangent here because there's no cotangent button. If you plug this in correctly, you should come up with about, and you can correct me if I'm wrong, 5.9551. Does that seem right for people that have their calculators? Yeah. Make sure you guys bring your calculators. Or make sure you go home tonight and practice this when it's fresh in your head. Because what happens if you wait too many days, all of a sudden you're like, what buttons did he push? Are we good with plugging in our calculator? It seems like it'd be easy questions on the test, but sometimes it can trip people up by either you don't practice it, you don't know there's a mode button, you don't understand what to do if there's no secant button or cosecant. All right, cool? Cool. All right, guys. Here's what I'd add to my unit circle. I would add the tangent values. So I would take out my yellow sheet and I would add tangent values to this. Now I'm going to note some specific things about tangent that are weird. If you look down here, tangent is 0. It's not just regular 0 though. What makes it 0 is it is sine over cosine, so it's 0 over 1, which equals 0. So we have 0, square root of 3 over 3, 1, square root of 3, and all of a sudden it's undefined.
Do you have to write that?
Yes. Because if I ask you for the tangent of pi over 2, you must put it's undefined there. Why is it undefined at pi over 2?
Anything over 0 is undefined.
Why is you can't divide anything by 0. So it's not just regular undefined. We know why it's undefined because it's 1 over 0. What would happen if I took the reciprocal of 1 over 0? Out of 0 over 1, is that a real number? It'd be 0.
Is what?
So if you're dealing with cotangents, you got to realize that undefined, if I flip an undefined, it actually turns into 0. If I flip 0, it turns into undefined. So where tangent is undefined, cotangent is 0. Where tangent is 0, cotangent is undefined. Would it be easier if I just had a cell phone thing for you guys to put it in? Or can we be okay with cell phones? So I'm getting kind of sick of people on their cell phones when I look up. Okay. So I would add all the tangent values all the way around. I'll put this back up in a second for you guys to be able to put this on there. I want to get us started on our homework. Our homework has some additional things I want to start thinking about. So I have theta equals 150 and I have theta equals 7 pi over 4. I want to make our life a little easier so we don't have to always look at our entire unit circle. What quadrant is 150 in? Second quadrant. If you're in second quadrant, that means sine is positive, cosine is tangent, cotangent, secant. Close. It's the one that's wrong, so that would be the cosecant would be positive. So I already know these are positive or negative. Does anyone remember the reference angle of 150? 30 degrees. Yep. A reference angle is how quickly can you get to 180 or 360. 30 is the quickest. So now I'm really looking for what's the sine of 30 degrees and make it positive. What's the cosine of 30 degrees? Make it negative. What's the tangent of 30 degrees? Make it negative. That way I can just know quadrant 1. Because we should know the sine of 30 degrees from the other side is 1/2. What quadrant is 7 pi over 4 in? Fourth. Is sine positive or negative in fourth quadrant? All students take calculus, so sine would be negative. Cosine, positive. Tangent, negative. Cotangent, negative. Secant, positive, and cosecant is negative. Remember, in any quadrant, only one of the prime ones is positive. So in quadrant 4, only cosine can be positive. The reciprocal secant's also positive. Everything else has to be negative. It shouldn't be a lot of thought process. You should just know what's positive. That's your goal. In quadrant 4, cosine is positive, which means secant is positive. Everything else is negative. Not a bunch of thought process. You don't even have to know what cotangent or tangent is. You just have to know it's all negative, cosine, and secant. What's the reference angle of 7 pi over 4? Ooh.
No.
Nope. You're overthinking this. It's pi over 4. Just erase the number that's on the top. Pi over 4. So I'm asking, what is the sine of pi over 4? Square root of 2 over 2. What's the cosine of pi over 4? Square root of 2 over 2. You just have to add your positive or negatives in front of it. It could be that easy to turn everything into the first quadrant and know your values.
Have you found the reference angle for the degree one?
It's the quickest way to either 180 or 360, whatever's smaller. So you just got to ask yourself, am I closer to 180 or 360?
And then just whatever that
Yep. So if I was at 210, 210 is still closer to 180, it would still be 30 degrees. Not negative, always positive. Okay? If I had like 330, it'd be closer to 360, so it'd also be 30 degrees. So in fact, all of those angles would have the same cosine and sine values, except they'd be positive and negatives. So all of those angles I just gave you, this would be 1/2, whether it be positive or negative. All right, rest of the time is to work on your homework and to update your unit circle.